Welcome back to the channel. Today, we're going to build a predictive algorithm using the data we've prepped in our previous videos. We'll start by building out the model parameters. We find the minimum and maximum payment weeks in our dataset. This allows us to define the time frame for our actuals and forecast. Currently, there are 87 weeks worth of actuals and 39 forecast weeks. This approach allows us to instantly refresh our time frame as soon as we have updated data, but you can also make these hard-coded to provide greater user control. Next, we use a sequence formula to establish the first payment week with actuals all the way through the last payment week we are trying to forecast. Then we use an if formula to determine if that week is actualized or forecasted. After that, we can use an XLOOKUP formula to find the order week for each payment week. This will allow us to aggregate shifted sales. Notice I'm using pound signs in each of these formulas. I'm making use of Excel's dynamic arrays functionality, which allows me to apply the formula over an array of data that may grow or shrink, which is perfect for creating automated data pipelines. Next, we can aggregate our actuals using some ifs and average ifs. Notice that we only get actuals for actual periods, otherwise we return a 0. Next, we get into our first forecasted figures. These are not our main y variable, but rather the forecasted inputs for the algorithm we are going to build. You have to remember, we might train our algorithm on actuals data, but we are going to need projected inputs if we want to forecast future data. To do this, we use Excel's native forecast.ets formula. The syntax looks overwhelming, but it is simple. First, we pass payment week as the target date. Next, we pass the historical values for the data point we are projecting. A simple filter formula will accomplish this. Next, we pass the historical dates that correspond to these actuals. Again, the filter formula comes to the rescue. The final inputs are specific to seasonality and data completion. We will leave these as defaults or 1, 1. Let me carve out those two nested filter formulas to show why this is so useful. Column O gives us the historical values for shifted sales, and column P gives us the historical dates pertaining to those values. If I scroll down, the data automatically grows or shrinks based on which dates are tagged as actuals or forecast. This means that all I have to do is refresh my raw exported data in order to refresh and retrain my model. It's important that we only use actuals to inform the forecast. With the first forecast complete, we can just copy over the formula, ensure the references are correct, and we're done. I also recommend always tracking error rates between forecast and actual values. We want as low of a rate as possible, and we always want to be looking for ways to improve the error rate. Next, we need a little help from Python and Copilot. Think of Copilot as your coder that will build things exactly to your specifications. Let's give it some context and instruct it to do what we need it to do. The challenge with Copilot is every response is unique, so you may not get the same results I do. In fact, I've done this multiple times and I get slightly different results. That is okay and normal, you just need to engage with it. The best advice I've heard when it comes to utilizing Copilot effectively is to speak to it like a 7-year-old. A 7-year-old who is a master Python coder. After you click Start Advanced Analysis, Copilot will create a new tab and start working through and documenting the steps to the analysis. First, it loads the data and it even references the ranges where it pulled the data from. It then trains a linear regression model and predicts the variable, but something doesn't look quite right. We get -8003.1 over and over again. No problem, let's reopen Copilot and tell it to use actual data points to predict actual periods and the forecasted data points to predict forecasted periods. That looks much better. We don't need all of these fields, so we can modify the Python script really quick to only output the predicted receipts. Let's go into the formula bar where the Python script is housed and copy it. Then, let's initiate the new Python formula in a blank cell by typing =py and hitting tab. Then we paste the script and scroll to the bottom. Simply delete the payment week from the output and hit Ctrl Enter. Excel will default to a Python object output for Python formulas, but we can change this to Excel values, and boom, we have a forecast that utilizes a multiple linear regression algorithm. Finally, all we have to do is copy and paste this script into our prediction tab and we're done. Thanks for watching. Don't forget to smash those like and subscribe buttons, and if you did like this video, you'll love my newsletter, The Ref Report. I dropped a link in the description below.